first of all, we need to load libraries. So pandas is the most important library in Python. And pandas, pandas library gives you this opportunity to work with structured data, work with tabular format of data. There are a huge bunch of, let's say, functions, built-in functions in pandas that give you this chance, to work with data easily. So easily and straightforward. So that's the thing we want to do within today and next week, and relevant to your coursework. So let me run these libraries. So since data is CSV, let's import the CSV file. If you want to import CSV file, let's make a data frame. So why we need to create a data frame? Because as we said that we want to bring this data inside the table, because this is a tabular format. So this is a two-dimensional format. There is PD in pandas. There is a function we call read CSV. So read CSV, can we see, guys? There is read Excel, read CSV, read JSON file, read HTML file, read Parquet file, ORC file. There are different formats that you can, load data. So CSV. So what is the data? Titanic. If you type TI and press Control space, it's going to bring the name of the file, Titanic, right? So if you load data, it's better to to print out a few records of data to understand what is data. So df.head. If you say df.head, it's going to print out the first 5 records, right? First 5 rows. So if you run it, so it's going to say this is a data. So this one is an index. It says index 0 means first row, index 1 means second row, and so on. Passenger ID, survived. If it's 0 means I guess it's the guy yeah, I mean the person has been died. If it's 1 means survived. P class, the name of the passenger, sex, age, SIP SP, we need to know what is SIP SP, part, ticket, fare, the amount of, I guess this is based on dollar, cabin, and embarked, right? Means is he or she was on board or not. So let's see what they are. So in this case, you have to have a look into, this data dictionary, means data description. Where is that here? Data description. If you open it, it says, so 0 means survived, not survived, 1 means survived. So P class means ticket class, first class. If it's 1 means first class, 2 second class, and so on. This is sex, age. So SIP SP is the number of siblings or spouses aboard the Titanic, and part, number of parents and children, right? Ticket number, passenger fare, cabin number, and embark means port of embarkation, means C from this city, Q, or let's say this port. These are 3 different ports. So it seems it's well enough, right? We could understand this data simply with these, few, let's say with these few definitions. Okay, let's move on. So we could print out the first 5 rows. If you want to print out, let's say 10 records, you can say 10, right? It's going to print data from top, because we say head. It's going to print out data from top, the first 10 records, right? And you can simply find out. So as you can see here, we have several null values. So guys, having null values are really, let's say, I want to name it disaster, because we have to find a way to remove null values or replace null values. Null values will affect negatively on your analysis, or you will face with logical errors within your analysis. So it's better to find out how many null values we do have, which columns has null values, and so on. So based on this observation, we can see cabin is one of the features with null values. So we have to think about that, how to manage it. This is also the first task in your coursework. It's here. Where is that? It's here, manage null values. So that we want to discuss today. Okay, if let's say if you want to print out last rows is here, print last rows. If you want to print last rows, let's say you have to use df.tail. So df.tail means print out the last 5 records. Can you see that? So as you can see, this ID is 890. It means this is a data set, includes 891 records because indexing starts from 0. So it's somehow, let's say the medium size data, and 800 with 890 records. Same as head. If you say 10 or if you say 8, let's say 8 is going to print out the last 8 records, and then you can see that. Same as head, as you can see, cabin includes null value, and here we could find, one null value here for age. Can you see? This is our observation. We have to find out where they are because we cannot print out all records and see them and observe them, one by one. So we have to find a way to make it simple. If you want to print out, let's say, print out data randomly, right? You want to pick, let's say, 10 rows randomly to print out, to get well enough information. In this case, you have to call data frame and use sample. So if you say sample 5, it's going to take out 5 records randomly. Can you see that? Index 8, index 730, and different indexes. So if you run again, it's going to give you, other records because it's going to pick up data randomly. And here we can see more null values for, age column, and for cabin. Can you see that there are more null values? But we have to figure it out where they are exactly. So by observation, we could see they are in age and cabin features, but we have to figure it out more. So, I mean, these are enough to understand, what's going on about, loading data. Then you need to get more information about data. For instance, if you use df.info, info is going to give you well enough information about this data. So it's going to say there are 891 entries, means 891 records. Indexing starts from 0 to 890. Okay, great. Data column, it says there are totally 12 columns. So great. And these are the name of the columns. Right? And also the type. Can you see that? Integer. So integer object. So for string, pandas is going to say the type is object. So object means the data has string format. So integer. So name is a string. Sex also is string. If we check sex, can you see that? Sex is male and female. This is a string. So age is float. So because as you can see, it's 14.5, maybe it's 14 years and half month, something like this. And also there are null values. So if you use df.info, it's going to ignore null values and then give you this sort of information, right? And as you can see, it says age has only 714 records null value. So since we have 891 records, you can simply calculate it that there are about, let's say, 200 records, including null values in age feature. So or maybe here in cabin, can we see that 204 null values? There are many missing values in cabin that we have to think about that to how to sort it out. And for embarked, only 2 records are null values, because there are maximum 891 records and only 889 is null value. Okay, great. And object, can you see that? It says D types means data frame type. There are 2 float, 2 integer, and 5 object, means 5 string. And the size of the file is about 83K, right? Memory usage. Okay, well enough information about data. So guys, we are at this stage of, collecting well enough information about data. It's really important to understand data firstly, and then start working with analysis. So if you want to just print out, types, you have to use data frame types, because we are working with data frame. So it says only about, data type. So it's okay. Get descriptive statistics. This is the thing we practiced last week. Describe. If you use describe on data frame, it's going to take out those features, with numbers, not textual one, not string ones. It's going to remove strings, because if you remember last week, I've said descriptive statistics, descriptive analysis, or any kind of analysis, they are working on numerical data, not textual data. So it's going to extract, these 7 columns, float and integer, and to give you, well enough information. So you can simply, interpret this data. So this is the average. This is the standard deviation. So what I want to ask you within your coursework presentation, for instance, if you come up with this, let's say 29.69 for age as a mean, then I will ask you, what is that? What is mean, And then if it's standard deviation, I will ask you, what is that? Why we need a standard deviation, right? Whatever you have been done, or let's say whatever you want to do within your coursework, I will ask those, contribution. I'm not going to go beyond your contribution. Whatever you have done as your contribution for coursework, then I will ask those, those contributions. And these are about, person type, 25%. For instance, I would ask you, what does it mean? Like 20, 25%. So then you have to give me, information that 25% of people are 20 years old or less than 20 years old. Simple. You just need to practice last week tutorial. So this is also good, to get some information, out of this data. So, but the thing we missed is to how to get the size of this data. So here, this DF info, it says 891 increase and 12 columns. So by the way, we have the size of the data, but there is the command that we would say df, I guess df.shape, if I remember correctly. Yeah, df shape tuple object is not callable, so means it should be something like this. Yeah, it says 891 is the number of rows and 12 is the number of columns. So guys, as you can see, the output is parentheses. So parentheses means this is the tuple, the outcome, is tuple. If you want to get out only this one, the rows, what we need to do, let's say df size is df shape, and then here you would say row is df size. And then how to get access to tuple, we have to use bracket and 0, right? And then I want to extract columns separately, and this one, and then I want to say print the number of rows, and then you can say row, for instance, right? Something like this. The number of rows 891, or also you can print out columns. Okay, give me a minute. There is a phone call. I don't know who is he, or maybe she. Okay, so guys, till now we could collect well enough information about data, about the size of the data, about the data types, about the name of the name of the features, about how many null values we have, and so on, about the size of the data, you can collect. Also, we could print out, some records for more information. So I guess these are well enough to understand data. Then we have to stop before analysis. You have to decide about null values. What do you want to do with null values? Are you going to remove null values, or are you going to replace null values? So let's do start. Let's see how we can do that. So here, let's start with cabin. This one, where is that? Cabin, right? Because we had many null values here in cabin. And also, if you have a look into the information, it says, I guess there are more than 600 records, including null values. This is a huge number, right? We have to think about that, to how to sort it out. So, okay, let's go through these null values. We need to check nans or null values before data analysis. We can either remove or replace null values. So you have to see which one is the best decision, removing or replacing. So let's say if you want to work with a specific column, you have to call the name of the data frame, and then we have to use bracket. So bracket means I want to work with a specific column. Which column? Can you see that it's going to bring, this column? It says there are these columns. Which one you want? I want to go ahead with cabin. You can click on cabin, or you can type it cabin. So df cabin, if it say dot is null, so, and if you run it, so as you can see, it's going to say first row is true, means it's null. Second row is false, means it's not null. Third row is true, means it's null, and so on. But it's not really good, information to get this sort of information, because it's going to print out the first 5 info and last 5 info. So let me see if there is any question. Okay, no question. Let me mute all of you guys. Sorry about that. Otherwise, it's going to distract other student. Perfect. Let's move on. Okay, this is about null values. So not really good information about null values, because there are huge number of null values. But if you go ahead with this one, with embarked, so if I use embarked, oh no, by the way, no difference, because even if I use embark, it's going to print out this sort of information for all rows. Can you see that? False, false, false. But I want to find out which rows are which rows have exactly those null values, right? We have to figure it out. So let me see df cabin. So print rows including null values for a single column. Let's say I want to print out, data frame including null values for cabin. How to do so? Guys, this one, if it's true, means it's going to return this record. False means ignore this record. True means accept this record. False means ignore this record, and so on. If you want to print out null values, you have to print out those records that they are true. True means there is null value. So how to do so? You have to use df. So I want to use exactly this one. So then I wanna say go through, I want to use them as an index, and then df and this one. What does it mean? If you run it, this one is going to print out firstly true. So first row is true, means print it out. Second row is false, means ignore it. 2 is true, index 2 means print it out, and so on. If you run it, it's going to print out those record with null values, right? Null value, null value, null value, and all records are null values because here we said that is null, right? And then here we can print it out. So if you want to say print those records without null value, what we have to say here, I want to say this is null values is not null values. How to do so? Here you have to say this symbol to say not anything here, right? Consider it not means first row is true. This one means false, means ignore first record. False means convert it to true, so means print it out and so on. If you run it, it's going to print out those records without null values for cabin. Can you see that all cabins here are not null? They are, I mean, there are values for cabin. So this is a way you can print out your data. You can also do it for disembark. Where is that? This one where we are. Yeah, this one, embarked. So because embarked had, so if I say embarked that they are not null, so not null, so these are not null, but let's say let's do it with, okay, let me change it to cabin, and here I want to change it to embarked. Okay, this one. If you run it, so can you see that it's going to return only 2 records because these 2 records have null values for embark. Which one? Index 61 and index 829. Right? We could simply find out, you know, where they are. Null values. Let's say print null values, print not null values, something like this. So count nulls for a single data frame column. Where we are, count nulls for a single. Okay. Also, before doing that, okay, because we got well enough information here, so this number says we have null value here because they are less than 891. We have null value here, we have null value here, and we have null value here. But if you want to get them separately, I guess why not to say like df, I want to do it one by one. Let's say I want to start with cabin, or let's say start with this one with with survived. So let's say df survived. I want to see if there is any null value. So is null. So if you say is null, it's going to print out, you know, this useless output. We don't need that. So if you say is null, if you say it converted to values, means convert to values means false is 0 and true is 1. And then .any means if there is any one, number one. Number one means it's null value. If it's any, it says false. False means there is no null value for survive. Let's say check null values in each column. So we have done it for survive. If you wish, you can do it for, let's say, name. So name says false means there is no null value on name. And if you say age, it says true. So it means there are null values for ages. And how to find them out? How to find them out, you know, means how we can, now we want to count them, right? We want to count them. So if you want to count here, let's say, guys, this is like, you know, my technical contribution with this data set. I'm recording this session and I need you guys, I need your contribution, your engagement to practice, you know, these sort of, you know, coding, you know, let's say from now on, after today's session till Thursday, and then within Thursday again we do practice. So Python needs practice, you know, and with practice you can understand, you know, these syntaxes. Let me see if there is any question. Nothing yet. Okay, count nulls for a single data frame column. So let's say for this age, I want to count them, how many there are. So age, and then if you say is null, so means find null values, then you have to say like sum, means count them. So you say there are 177 null values in age column. So if you say cabin, so there are 687, is a huge number, right? And if you say for embarked, there are 2 values, right? If you say for name, so it says 0, means there is no null value, right? It's good. Let's say for cabin. And let's say I want to check nulls for a data frame. So let's say for a data frame. So in this case, you have to say the whole data frame, because here we had this practice on a single data frame, but here we want to do it over all data frames. So how to do so? Simple, just copy this one, right? And remove cabin, means it's going to be for all data. So if you run it, it's going to say there are but let's say use any, because it says just check the null values. If you say any, it's going to say true, means for age, means there is null value for age, there is null value for cabin, and there is null value for embark, and the rest are you know, safe. Okay, count null. So this is the thing I want to go ahead. df.isNull. So here we use .any, and here we want to use .sum. Then we can calculate. So can you see that it says there are 177 for age, 687 for cabin, and two rows for embark. So here, if you scroll it down, scroll it up, we did it on one single feature, cabin, but you can simply do it here over the whole data frame. You just need to simply remove, you know, this column. Whatever you added here, just remove it and use this isNull sum for whole data frame. So get the indexes of null values. So it's important because now we have to decide. So here we have to decide about null values, you know, to remove or replace, right? This is the practice we have to do so. So let's take 10 minutes break, and then I will go through the rest, and then we can see how to you know, remove those. Or let me complete it, because there are only 4 cells to be completed. There are the left cells. Okay, let me do these 4 cells, and then we can take a rest, you know, for 10 minutes for the rest of the practice. So get the indexes. So guys, now we have to get the indexes, like 177 indexes. We have to collect them and then decide to remove them or replace them. So let's start with this one, embark, which is just 2 rows, and then we can expand it, you know, we can do it the same for the other features. So if you remember from here, let me see where we are. Here, this one, I guess this one, right? So if I scroll it down, if we do this and if we run it, so it's going to print out null values, right? This is the syntax that we need to get null value, those rows with null values for embarked. So now I just need these 2 indexes, 61 and 829. So how to get them out? you have to use dot index, means I want to get those 61 and 829. And if we run it, so can you see that 61, 829? But the output is like the tuple. I don't need to have it like tuple. I need to have it like a list. So you just need to add two lists. If you say two list, can you see we have a list 61 and 829. These are the indexes, including null values. So now we can decide. We can decide what you want to do. Since there are only two records out of 890s, 890 records. So maybe in this case we can remove these null values, right? We can remove two lines. So how to remove, two records or two lines, two rows, whatever. So this is a syntax. So data frame, so here is df dot drop. So drop means remove rows or columns. You can remove both of them. So here we have to say, first of all, labels. Since we want to remove rows, we don't have labels. Labels is for columns, mostly for columns. So let's say index. So we have to start with index. So what is the index? So indexes are, this one, 61 and 829. So I can copy this one from here, right? You can simply put it there. But since this is long, I can do here indexes is this one. And I can get this one and put it here. Or let me say null for embarked. Maybe it's better. And then axis. So axis means you want to remove rows or columns. If you say 0 means I want to remove rows, right? And then what else? So axis we use, index we use, column we don't need that, in place. So guys, make sure to use in place. So in place means you have to have it true. So in place means remove these rows from the same data frame. If you don't add it, if you don't use it, you have to create a new data frame like data frame 1. And then in this case, you have two data frames. So for, in terms of memory usage, we don't need to have, one more data frame. So to avoid it, in place means do these action over the same data frame. So also here, if you run it, so it's done, right? You can see that it's done. But how we can see the result? We can open another one, and here with the command is null with dot sum, we can find the result. So can you see that embark now is 0 because we removed null values? Null values of those records for embark, these ones. We removed these two records, record index 61 and record index 829. So this is simple for drop. And also for your task in this coursework, you have to find out those features with the minimum number of null values. Then it does make sense, to remove those records. But for the rest of them, like for the cabin number here, that we have 687, or for age with 177, it's really not the good solution to remove those records. In this case, you will miss most of information. So for this reason, we have to replace null values. So let's think about drop a column. So here we have these columns, right? We have this column. Let's say I don't want passenger ID is useless. Maybe you want to say sibling and parents, this one maybe is useless. You don't need them. So if you don't need them, you can drop a column. So how to drop a column? We have to use the same command, this one, df.drop, df.drop. So if you remember here, we had columns, right? Columns. Oops. So columns. So here I want to say columns, or which columns? So passenger ID and ID and SIP. What was that? Is here CSP, right? And again, axis means I want to remove data in column from the column. So and then in place, make sure to have it. In place means do it here, and then if you wish, you can say df.head to check the result. I guess you can also remove this one. You don't need to mention it, but by the way, we can use it. So if you say df.head, can you see that we don't have passenger ID? It has been removed, and SIP it has been removed, right? And now we have a data frame, with this information. So we could learn how to drop null values from records, from rows, and now we could remove column, unnecessary columns. And last part is replace null values. So how to replace null values? So to replace null values, let's do this practice. I want to collect this one, because for age, let's say I want to do for age. So here I want to say null age, and then here I would say age. What is that? It's going to collect indexes including nulls, something like this. Okay, we can collect it. And also, if you type it null age, can you see that these are the indexes, right? Many indexes, 177, right? Yeah, 177. So index 5, index 17, index 19, and so on, right? These are indexes with null value. So as I said, we don't want to remove them. We want to replace them. How to replace? So we have to work with the location of the data, because I want to replace values with these location. What does it mean? It means I want to remove I want to amend, I want to replace this value, I want to replace this value, right? The single values, not the complete row, not the complete column, only this one, only this one. So how to work with that? You have to use df.location. So this is a practice that I want to discuss in this part, retrieving specific data. So let's do it here, and then we will discuss after the break. So df.look, which location? So you have to give row and column. Means since this data is two-dimensional, you have to mention which location. This location null age, because null age is going to return the index of the rows. So what about column? This column, age. So here you have to say age. So what you want to do, I want to say get df age, for instance, and use the mean. So means go through this column, calculate the mean. So if you use descriptive statistics usually remove null values. So it means we can simply do it here. If I say df mean, it says the average of ages is 29.64. It means fill in null values with this value, 29.64. So, and then here, if we run it, so how to work with location? There are two ways to get to a specific data. iLocation means index location, and location, look. iLook and look. So we know that the syntax is, rows and columns, because we have two-dimensional data, rows and columns. So we have to think, and we have to, have a solution to go through both of them, rows and columns. If you use iLook is going to be integer location based indexing. So for instance, if here df dot iLook, so then bracket, this is a syntax. It says you can use simply one number. Let's say I want to put number 5. If you run it, it's going to return row index 5. Let me see, do we have it here? 5. So means 1, 2, 3, 4, 5 means index 4. It's going to return these rows, and as you can see, where is that? Is here 0, 3, and so on. Right? This is iLocation, means return index 5, means starting from 0, it's going to return location 5, or let's say row number 5. If you wish, you can put the array of integer like this one, 4, 3, 0. I mean, you can shuffle them. They don't need to be in order. So, but if you want to do so, you have to put it inside the bracket. So can you see that? It's returning index 4, index 3, and index 0. So I guess I made a mistake here. So 5, it's going to, yeah, I made a mistake. 5 means index 5, means not this one.
See.
Yeah, sorry, go on.
We don't see.
You don't see? But my screen is shared. Let me share again. Really strange. So now can you see?
Yeah.
Okay, let me do it again. I'm really surprised. So I've said we have 2 ways to get access to a specific data, right? iLook means index location, and look. If you use iLook, means you have to give rows and columns IDs by a number, like df.iLook. If I use iLook, let's say number 4, so it's going to return index 4. So where is index 4? Index 4 is here, this one. It's returning this one. If you want to return more rows, like this one, 430, for instance. So as you can see, you can shuffle indexes. Means index 4, index 3, index 0. So if you run it, can you see it's returning index 4, index 3, and index 0. Or you can use like this one, 1 to 7, means I want to return indexes 0 to 7. 0 to 7. Okay, I have to remove it. Right? Can you see that index 0, 1, 2, 3, 4, 5, 6? So can you see, remember, can you remember, guys, this one? This is a slicing. Slicing, this is from week 2. If you remember week 2, I've said slicing is start, stop, and incremental step, right? So means the last one, 7, is not counting, means start from 1 to 6. This is what exactly you can see, 1 to 6. This is a slicing. Or for instance, let me add one more thing. So df.iLook. So let's say for rows, I want to return rows 2 to 4. And I want to, this is for rows, right? This is only rows. Here we practiced only rows. Here we practice only rows. Rows 1 to rows 6. What about column? I want to mix both of them. So rows 2 to 4 and columns, let's say column 3. Sorry guys, I have to remove this one. So if you see here, it says column, yeah, 2 to 4. What does it mean? It means this one, 2 to 4. So I've said this is a slicing. We have to ignore the last one is 2 and 3. So we are talking about these 2 rows, 2 and 3. So which column? Column 3. How to count column 3? 0, 1, 2, 3, right? Means female, female. This is what exactly we can see, female, female. So, or you can say, if you want to print like, let's say 1, 2, 3. So can you see that? It's going to do rows 2 and 3, these 2 rows. What about columns? Columns 1 and 2. Again, this is a slicing. Guys, this colon means a slicing. You have to ignore the last number. You have to have it one number less. Means column 1 and 2. Column 0, column 1 and 2 means P class and name. Can you see that? P class and name. And then print out only these information. I mean, these three, these 2 P class and name, and also this, right? This is what we can see here. So this is the way you can get access to specific data. So where we have been used them here for null values. Can you see that for null value, I've used location. And also I want to give you information about location. Here, okay, let me tell you location and then I will go through that. So conditional statement, it means let's practice location. So location, you have to assign a label. So can you see that like A? So location work for usually column. For instance, if I say let's say df.location. So df.location, if you say, for instance, 1 and 2, it gives you error, right? Because location works with label. One of these indexes, rows or columns, should be labeled. Let's say I want to say index means row 1, and then index ticket. So can you see that it says PC, I mean this output. How to find it out? It says row index 1 and ticket. So this is ticket is here, right? This is ticket. And which row? Index 1. So which one is, this is exactly index 1, right? Means this is the output. So the big difference between location and iLocation is, in iLocation you have to work with numbers. For location, you can use label. This is the only difference. So, and since this data has label only on columns, then you have to use labels here only in the column part. But if your rows, since here the rows are numbers, means we cannot use label here in the rows part. So, or let's say, for instance, I want to print out location of let's say rows are index 0 to 3. Again, this is a slicing, means 0, 1, and 2. First 3 records. Where we are here. This one, these 3 records. 1, 0, 1, 2. Let's say I want to print out name, age, and P class, right? This one. How to do so? Simple. This is with comma, you can separate them. This is row. What about column? Again, you have to open this bracket to make a list of this column name. You can shuffle these columns, right? P class. And if we run, so P class not indexed because it's case sensitive, P class. So as you can see, we could extract 0 to 3, and okay, there is a big difference. This is name, age, and P class. Could you see what is the difference? Because here we said 2 and 4, it ignored 4 because of slicing in iLocation. But for location, it also counts 0 as well. Can you see that? 0, 1, 2, 3. Okay, great. So for location and I location is also another difference. I just observed that. Let me mention it here. Difference of iloc and loc is the last number of slicing is counting in loc. Okay, good to have it here. Let me see. So here it says we can have conditional statement. For instance, I want to use location. Which location? I want to print out those records. Let's say the age is more than 30. So how to do so? You have to say df age. So how to get access to this age? So it's simple. We have to say df age, right? Greater than 30. So those location where df age is greater than 30. If you run it, it's going to send, you know, this output 38, 35, 35. Can you see that they are all greater than 30? So guys, really it needs practice. You cannot memorize them. You just need to practice. So for instance, let's say I want to print out those records that the ages are more than 30 and cabin is also null. So it means I have two conditions. So first condition, I want to say if I use this one, let me do this one, df. So let's see if I use this one. So the output is, can you see that the combination false true means first row it's not greater than 30. Second row, yes, the age is greater than 30. This index 2 means third row, the age is not greater than 30. Can you see that? We can get these combinations of false and true. So we can keep it in let's say in a variable called mask age to collect these false and trues. And also I can create another one. I want to name it cabin, mask cabin, and I want to say df cabin, this one, cabin, not null, right? Means get those cabins that not null. If you say is null, it's going to collect the null values. If you say not null, means get not null values. Then I want to print out only these records, right? Including ages more than 30 and not null value for cabin. So I have to use again df loc. Guys, I want to use loc. Why? Because here I have indexing age and cabin. So df location. So here I have to use mask age. And how to mention and in Python? This one. At this ampersand and then mask cabin. So if you run, yeah, great, it's going to return columns. It says there are 114 rows, including ages more than 30 and cabin is not null. And also we can check that. Can you see that cabin is not null, usually not null. And I guess without location also we can use that. So this is the reason Python is, this is the reason I love Python, because whatever you think, you can write it. This is the concept of Python. So I'm thinking, you know, I can remove .loc. And if you remove it, can you see that you can again, you know, get the same result? This is the reason Python is really high-level programming language. Whatever you think, you can write it. Okay, these are same. Also, I can do it here. Okay, these are about location and these are about location and index location. So please do practice. It's really simple, really simple. You just need to practice. Let's talk about sorting. Let's say I want to sort data based on age. Sorry, based on age. Yeah, I want to do that. So how to sort that? You have to call data frame, right? Dot, then use sort values. So sort, let me see, sort values. So if you use sort values, the important input is, where is that? Not here. No, not here. Let me check. Axis ascending, in place, kind, cache, key. Okay, let me name it. So I wanna sort age. Let's say age. This one, age, right? How I wanna sort this data frame? I have to say ascending is true. Let's say false. If we run it, so as you can see, it's going to print out from the largest value in the descending order, 80 years old, 74, 71, 71, and so on, right? So also, I guess we can add by here. If I remember, we can also add by. Yeah, great. Yeah, both of them work. So let's remove it. Okay, we could sort it. And let's say I want to sort based on two columns, age and, so if you want to do so, you have to put it inside the list. So I want to sort based on age and, let's say, name. So ascending is false. Ascending is false means for both of them, it's going to firstly, look at here, guys. It's going to firstly apply ascending on age. So it's 80 and print out, you know, the value for name. 74, the value. Since there are two ages like 71, then for second one is going to consider ascending order. That's the reason. First of all, it's going to print out gold and then orthogonaly, orthog, orthogo, sorry, I say orthogo. So that's the reason. First we have gold and then orthogo. And also maybe it's going to be like for this one. Can you see that? Two similar ages. So it's going to apply this ascending order for name. So Baclini means same, and here is H, right? And then E. That's the reason it's on top. But if you want to apply, let's say descending, ascending approach on name, you can do here. So false and true. So it's going to apply false for age and true for name. Means for name, please have it ascending order. If you run it, so as you can see, 71, 71 for age. Since we said name, the ascending is true. That's the reason it's put firstly A and then G, right? That's the way you can sort. If you want to sort, for instance, this one, let's say I want to sort this one. How you can sort it? You have to create a new data frame like this one. Let me do it here. Like data frame 1, something like this. Right? And then here you can use this one. And then you can use df1 sort value. Right? And then it's going to sort values on df1 where you could, you know, get your own data and then sort them. So this is about sorting, about series. So series, guys, okay, when we say, let's say df age, So dfh means that the output is the series. If I type it, can you see that this is we call series? So series means, I mean, each column we call series. This is series cabin, series fare, series ticket. You know, this is the naming convention provided by pandas. So why we need that? For any, it says in a pandas data frame, PD series is the one-dimensional array with the labeled base index, means column. So why we need to learn that? Because for each column, you can simply apply descriptive statistic. Use .mean is going to return, you know, the average of age. You can use standard deviation. Is going to return a standard deviation. You can use you can find, let's say, maximum value, right? It's going to say maximum value, right? These are really nice to know that for each column you can apply your descriptive statistics. When you need that, you need it here. Descriptive statistics approach. So apply your own descriptive statistics approach on 3 columns and then visualize your finding. You want to visualize, use the graph, or you can use, you know, numerical output like this one, right? This is what exactly you need to do. Or let's say I can do something like this, df for age. Why not to keep them here for your reference? Mean standard deviation. And if you want also, you can print, you would say the mean of age is something like this. If you want to change this age to, let's say, guys, make sure you have to apply it on numerical columns. Means you cannot apply it on, say, you cannot apply it on name because these are textual columns. So let's say on fail, for instance. And then here you would say print the standard deviation of fair is this one, right? You know, whatever you want, you can do it simply. You just need to apply Python code in your own way. So let's say I want to find out unique values. So unique values means how many values, not duplication, means remove duplication. If I use .unique, so it says these are unique and output is array. So you can simply use toList to have it like this as a list. It's more, you know, readable. So these are unique. Ages means there is no duplication, right? These are unique values for age. And also we practice this one for null values. Let me see. Age is null, right? And then dot sum, something like this. It's going to, there is no null value. And I guess we can do something like this as well. Age, instead of using is null, say has nans. I do hope that there is has yeah, has nans. Yeah, great. So these are same, is null dot sum or has nans, or even here you can say any, right? Value dot any, right? These are same. So adding a column. So let's say I want to add a new column. So this is my data. I want to add the column at the end. So how to do so? Simple. You just need to say df and then the name of your column, new column. So what I want to add, let's say I want to add column age. I don't know, let's say df. Let me see. Survive is number also, survived. And if you say df.head, okay, can you see new column at the end? It's going to add age 22 plus 0 is 22. 38 plus 1 is 39. Right? You can see that. It's up to you that how you want to do, but we will practice with these sort of practices next week, next Monday. So I just want to give you, well enough information about these syntaxes, and then we will practice more. So if you functions on Panda service, okay, this is really nice link. If you go through this link, if you see there are many methods, length, lowercase, match, normalize, partition, guys, replace, rindex, offline, many Python functions. Please feel free to use these functions for your coursework. So I want to give you a few examples today and next week, and it would be up to you that how you want to use them. So for instance, I want to create a new column. Let's do this example. df, I want to name it the length of the names, length of name. This one. I want to calculate, to find out the length of each name. So how to do so? I want to create a new data frame. Sorry, new column. So then df name. So how to find length? So here it says we have to use series. So series is exactly this one. This is series, df name. Then use .str.length. So .str.length. And if I say df.head, so can you see that length name, 23 characters of this one. This is 51 character, and so on. We could simply do that. So whatever you want, if you want to convert them to lowercase, right? Just simply say str.lower. So just say str.lower, right? You can simply change it to lower. So yeah, I mean, you just need to learn these methods. There are really, many methods that you can apply by your own. So you can use this method within this descriptive statistics, or you can use within this one, task 5. Create the function to do a specific task. I want to give you more information about this by next week. So, and also, okay, 2 part left. So renaming columns. Let's say these columns, again, guys, if you want to remove columns, simple. If you want to remove new column, you think you wrongly added, you have to use df.drop, right? df.drop. Where is that? On top, right? We practiced drop. So I don't want to repeat that because we have drop here. Where is that? This one, right? Drop a column. Then you can drop it. So now I want to rename a column. So in this case, you have to say df.rename. Let me see. Yeah, rename. So df.rename. So I want to change, let's say new call, and also this survived. I want to change the name of these columns. So how to do so? Here you have to say columns. Let me make sure if I'm right. Yeah, columns. And then here we have to input our data as a dictionary. I do hope I'm right. Yeah, as a dictionary. So let me see. So if you remember, dictionary needs a key. So here the key is new call. Let me check. Yeah, new call, but C is capital. And then values. So the value is, let's say, I don't know, let's say calc. I want to rename it to calc. And another key, another key is, let's say that survived. I want to rename it to, let's say, flag. Okay, it's done. And then here, if I say df.head, can you see it hasn't been changed? Survived and new column. I guess we need to add in place. In place is true. Great, yeah. Now we have it. Flag and calc. Make sure to add this in place, means to apply over this data. So this is renaming. It's really simple. You can rename your columns and visualize data. So there are different ways to visualize data using Matplotlib. We practiced it, guys, 2 weeks ago, and you can work with that. There is a nice visualization using Seaborn library that we have been loaded here. Where is that? It's here, right? Seaborn, SNS. So let me go through this link. So catplot. So catplot is really nice visualization. Seaborn is a Python data visual library based on Matplotlib. It's high-level interface. Okay, great. What about catplot? So catplot has these information, this sort of input. Cat. No, I don't. Okay, let's apply it here to see what's going on. So for catplot means category plot, right? So this is a syntax. So seaborn.catplot, so cns.cat plot. So then here, okay, can we see that X, Y, hue? So X, so what you want to print out as a date, as an input, X is, let's say I want to print out, the column sex. So before that, you have to say kind. Let me check here, kind. Plot corresponding to the name of the category called plot function. No, data. So data is a data frame. So here, data, here I have to say data is df, right? This is the data frame we have to call. And then in this data frame, I want to print out this column as X. I want to print out sex. How you want to print out, guys? Here you have to add, I guess there is kind, yeah. The kind of plotted row corresponding to the name of the category called access level plotting function. So it means how you want to print out. You want to count, you want to use bar chart, point chart, violin chart, box chart. Can you see that there are different type of chart? Means kind, I want to count. I want to count this sex column and then visualize it. Let's see what's going on. Okay, perfect. Can you see that? It says there are close to 600 males and there are about 300 females in the data, because I've said this is the data go through sex, right? As an input, you have to mention it by X. And then kind. Kind means what you want to do. I want to count them. Simple, right? Visualize the number of genders. Good job. And here it says gender distribution among classes. Hue encodes the points with different colors with respect to the target variable. Okay, let's see what is that. sns.catplot. Guys, this catplot is a sample. You can use it in your coursework, or you can use Matplotlib. It's up to you, because this coursework is really open coursework, and I want to see how you want to analyze the data. So here again, I have to say data is df. So X is I want to work on P class, because I'm asking gender distribution among classes. So guys, here we need two inputs, class and gender distribution. So XP class, and then I want to count them. Kind is count, right? And then I guess I need to add Y as the second input is sex. X and Y. So let me find. Okay, if I run, either must be none for kind count. Okay, it says we can use only one input. So what about second input? In this case, we have to use hue. So what is hue? Where is that? Okay, XY hue, names of the variable. But what exactly hue does? Hue encodes the points with different colors with respect to the target variable. So target variable is sex here. So if we run, so great job. So it's going to say there are three classes. Can you see the first class, second class, three class? Sorry, first class, yeah, second class and third class. And for each class, it's going to count male and female, male and female, male and female. And you can simply find out for third class, there are many males, right? And yeah, this is another way you can use Catplot to visualize two columns together, P class and sex. And here I've used count. You can use different type of, techniques. Here it mentioned, right? These are the techniques available. So guys, again, these are really based on, the practice. So let's say use a box plot, means this one. Box, I guess this one box. So let's try. So SNS dot cat plot. So data is data frame, X is fair distribution. So fair distribution, and what else? No, fair for it says for embarked and fair distribution. So it means, okay, now it's good. So X and Y. So can you see that, guys? We have two inputs here, fair, but since we said embarked, and then fair. So, and then kind is box. So guys, if you say count, it gives you again error. Because if you remember, it says if you want to use count, you need to have either X or Y, means only one input. Since here I have two input, I have to use box. Could interpret embarked. Okay, nice. So it says, can you see that the X is embarked, SCQ, and Y is fair. It's going to visualize boxes, means box plot. Guys, box plot is 5-number summary. We discussed it 2 weeks ago. Oh, sorry, we discussed it last week. Box plot. So it means print out box plot based on two inputs, X and Y, and this is the result. And you should know how to interpret, this information. So this is very small box plot. There are a few outliers for, these embark, or let's say this port. We have also these outliers. How many outliers? 2, 4, 5. There are 5 outliers, means there are these 5 numbers are out of normality, and so on. Yeah, these are well enough information that we can collect.